There are two basic types of electrical current: direct current, or DC, and alternating current, or AC. In a direct current system, the electrons flow through a conductor in only one direction. Here's a simple example of how this works. As you can see, the electrons leave the battery and flow through a wire to a light bulb. After they flow through the bulb, the electrons flow back to the battery in a continuous loop. So you can see that in this example of direct current, the electrons are flowing in one direction only. DC electricity can be produced by a number of different devices. These include batteries, which are probably the most familiar source of DC energy, solar photovoltaic cells, and DC generators, such as those used in wind turbines and other small renewables projects. Using DC generators can be problematic since the electrical grid operates on alternating current. And so, when used in the grid, DC power must be converted to AC using a device called an inverter. While DC electricity can be produced from a large variety of sources and has some advantages due to its simplicity, it also has several economic disadvantages when compared to AC electricity. Chief among these are higher line losses under most conditions and higher capital costs associated with the larger wires that would be required to economically deliver DC power to customers. However, under certain conditions, high-voltage DC transmission lines, or HVDC, can be beneficial and are at times used to move large amounts of power over long distances. The second type of electrical current is alternating current, or AC. In an alternating current system, the electrons periodically reverse direction of flow. The electrons flow through a material in one direction and then reverse their path and flow back in the other direction. This happens over and over again at a rapid rate. In fact, in U.S. systems, the current changes direction 120 times per second. Here's a simple example of how this works. As you can see, the electrons start out flowing through the circuit from positive to negative, but then periodically switch and flow back through the circuit from negative to positive. Again, this happens much more quickly than can be shown here. While DC electricity can be produced by multiple devices, AC electricity is produced only by AC generators or by converting DC electricity to AC using an inverter. With the exception of a limited number of high-voltage direct current, or HVDC transmission lines, almost all of the electric grid today carries AC power. This is because system designers decided to use AC power early in the development of the electrical grid, since it is relatively easy to convert voltages from high to low using devices called transformers. This allows higher voltages to be used to transport power long distances, thus reducing losses and allowing for smaller and cheaper conductor sizes. Power is then reduced to the lower voltages used by appliances and other equipment as the system reaches customer facilities.